So now that we've covered each of the steps of text pre-processing, let's put this all together in a practical lesson, where we'll be running through each of the steps using a more realistic dataset. We'll start by importing the packages we need. So we want the NLTK package, and from nltk.tokenize, import word tokenize. From nltk.stem, we want to import the porter stemmer and the WordNet lemmatizer. From nltk.corpus, import the stop words, and we also want to import the RE package and import pandas as PD. We're now ready to load in our dataset. So we want to create our data and use pd.readcsv and read in TripAdvisor hotel reviews.csv. As you might have guessed, this dataset we're going to be working with is a set of hotel reviews. Let's use data.info to see what we have. You can see we've got 109 entries, so 109 rows, and no non-null values, which is perfect. Now let's use data.head to take a look at our data. We can see we've got two columns, one for the text review and one for the rating associated with that review. Let's also take a look at the first review in more detail. So we can see it's talking about a nice hotel, expensive parking, got a good deal, just a typical hotel review. So it looks like most of this data is in lowercase already, but let's just run our lowercase function just to make sure. We'll create our review lowercase column, where we'll be taking the review column and using .str.lower. Let's run data.head to check this has worked. The next thing we're going to do is remove the stop words from this dataset. So if you'll remember, we want to create our en stop words and use this as stop words and specify the English language. I've also decided I want to make sure the word not is not within the stop words, so we can use .remove to remove the word not from our list of stop words. Then let's create a new column, review no stop words. Using the join function, we'll go through each word in the string, and if it's not in the stop words, we'll use the join function to join these words together with the space in the middle. When you're pre-processing text, it is always worth making a new column for each of the steps in your pre-processing, so you can check it along the way, and if something messes up, you can just go back to the previous step in that relevant column. Let's check our working by looking at the first review we pulled earlier and seeing how it's changed. So this review is pretty clean to start with, but we can see that it has had a few words removed from it. And everything's in lowercase, so we're perfect to move forward to the next step. Let's now tackle the punctuation in our text. We want to remove the punctuation, but we notice we've got a few reviews with the star symbol instead of the word star. We want to keep this as it might add meaning to the review. We can do this with what we learned about regular expressions. So we'll start by creating our review no stop words no punct column. You can see we're using the R to indicate a raw string, and then we're looking for the star symbol, and we're going to replace it with the word star. We'll be looking in the review no stop words column. So this should hopefully find all the occurrences of the star symbol and replace it with the word. So if you look at line 2 here, you can see that the 4 star is in the original review, but in the column review no stop words no punct, it's been replaced with the word star, which is exactly what we wanted. Now this has been taken care of, we can remove the rest of the punctuation. We'll just be updating the review no stop words no punct column. If you'll remember from lesson 2.4 on regular expressions, The regex syntax we want to use to remove punctuation is square brackets, caret, \w, \s. So it's going to be looking for anything that isn't a word or isn't a white space and replacing it with nothing, essentially just removing it. Amazing, we can see that all the punctuation has been removed from our text. The next step to work through is tokenizing this text. We'll create a new column called tokenize. So we'll take lambda x and word tokenize x and the column review no stop words no punct. So we're tokenizing our cleaned up data. Let's take a look at that first review again. So this is looking good now. We can see that the text has been tokenized, all the punctuation's been removed. It's a nice and clean data set for us. The next step we're going to look at is stemming. So we'll initialize our stemmer and name it PS and reference the porter stemmer function. We'll then create our stemmed column. We'll take our tokenized text from the tokenized column, apply a lambda function for the tokens. So we're going to run ps.stem on the token for each token in our tokens list. So if we now look at data.head, we can see that the words have been stemmed. Let's compare this against lemmatization. So we'll create our lemmatizer using the WordNet lemmatizer function. We'll then create our lemmatized column. And similar to the code above, we'll be applying a lambda function over the tokens using the lemmatizer.lemmatize function. Let's take a look at that first review one last time to see how it's been lemmatized. So we can see a lot of the words have retained their original word and haven't been reduced down so much as compared to when we did the stemming. So we now have a nice clean data set that's in lowercase, it hasn't got any punctuation, it's been tokenized, and we have a stemmed and lemmatized version. Let's see what this looks like now and get an idea of what's in our data by looking at the n-grams. The first step is just to create a single list of our cleaned up tokens, so removing them from the data frame. We can use the sum function here and sum our data lemmatized column with just an empty list. This will put all of our tokens into just one nice list for us. Let's now take a look at the most frequently occurring unigrams. So this is the most commonly occurring tokens in our dataset. We want to create a pandas series, so we use pd.series and then use the nltk.ngrams function. The first argument is our token, so here we specify tokens clean, and the next argument is the value of n. Here, because we're interested in unigrams, n is 1. We then want to do the value counts of these different tokens. So if we print this out, we can see that the most common word in our data was the room hotel, followed by room, great, not, and stay. Let's swap this out for bigrams now. So we change from unigrams to bigrams, set the value of n to be 2, and print out our results. So here again you can see there's quite a few occasions where great location appeared together, Space Needle, Hotel Monaco, etc. So this gives you a really nice idea of what kind of topics and what kind of themes are coming up in your data without having to do any kind of difficult or time-consuming analysis. This is really interesting, like I said, to just get a really nice feel for what's in your data, what's coming up, and it's just nice to be able to check your pre-processing and just get that good understanding of your dataset before moving on to any kind of advanced analysis.